Hey everyone, and welcome. Think about it. Every single app on your phone, every website you browse, it's all built on this invisible foundation of data. Well, today, we're going to go behind the curtain and actually look at the architectural blueprints of that digital world. Yep, we are talking all about SQL.
And this is a really serious question. I mean, if you have a flimsy data structure, the whole system can just collapse. So how do you build something that's not just solid, but scalable and secure right from the get-go?
Well, that's the secret. You have to start thinking like an architect. See, a great database developer isn't just slinging code. Nope. They're designing a structure. They're making these really careful, deliberate decisions about the foundation, the materials, and all the rules that are going to hold this thing together for years and years.
So in this explainer, we're going to grab those blueprints and all the right tools, and we're going to actually construct a database right from the ground up. It's time to go from that abstract plan to the real deal. So you know the drill. Put on your hard hat, and let's get to work.
All right, first things first. SQL. It isn't just one single tool. A better way to think about it is like a master toolkit, right? And inside, you've got 4 specialized teams, and each one has a very specific job to do on our construction site.
So you've got your DML, that's for manipulating the data. Think of them as the furnishing crew. Then there's DCL, which handles security. They're installing the locks and alarms. TCL, they're the project managers, making sure everything happens in the right order. But our focus today, the star of our show, is DDL, the data definition language. This is the crew that pours the foundation and puts up the entire steel framework of our building. Okay, so before you can even think about building, an architect has to choose their materials, right? And in our world, in the world of databases, our materials are called data types. And let me tell you, picking the right one is absolutely crucial. It's what makes sure your structure is efficient, fast, and doesn't just, buckle under pressure. Let's start with integers. Just think of these as your support beams. And just like in real construction, you wouldn't use some massive, expensive steel girder where a small wooden beam would work just fine, would you? The rule is so simple. Always choose the smallest type that can reliably do the job. So yeah, for a person's age, tiny int is perfect. But if you're building, say, a global banking system and need a transaction ID, oh yeah, you're going to need the massive capacity of a big int for that. Now what about numbers with fractions? Here we've got 2 very different kinds of materials. On one hand, you have decimal. Think of this like a precision-engineered part for a Swiss watch. It stores the exact value, which is why it's the only choice for anything financial. Then you have float and double. These are for approximate values, which makes them great for things like scientific measurements where tiny little rounding differences are totally fine.
Okay, I'm going to say this again, and I really want you to listen, because this is probably the single most important safety warning for any database architect ever. Never, ever use float or double for storing money. Seriously. Those tiny little rounding errors, they seem so harmless, right? But when you add up millions and millions of transactions, they can cause catastrophic financial mistakes. So remember this. For money, it's decimal. Always. No exceptions.
All right, let's talk text materials. Your most common choice here is going to be between char and varchar. The easiest way to think about it is this. Char is like a standard-sized brick. It always takes up the exact same amount of space. This is great for data you know the length of, like a 2-letter country code. Varchar, on the other hand, is more like an expandable material. It only takes up the space it actually needs. That makes it way more efficient for things you can't predict, like a person's name or an email address. So long story short, VARC is your super versatile go-to material for most of your text needs. But when you need to store something really big, I'm talking about the entire body of a blog post or long user comments, that's when you bring in the heavy-duty stuff, text.
Okay, this next one, this is a distinction that trips up a ton of people, so lean in. Both datetime and timestamp store date and time, but they have one absolutely critical difference. Datetime stores the time as is. Think of a flight departing at 8 a.m. local time. That's it. Timestamp, though, is time zone aware. It actually converts the time to a universal standard, that's UTC, when you save it, and then converts it back to your local time when you look at it. This makes it completely essential for system stuff like a created at field in a global app because it guarantees everyone is on the exact same consistent timeline.
All right, we've chosen our materials, the blueprints are finalized. You know what that means? It's time to break ground. We're about to turn our logical plan into a physical reality, and we're going to do it with the most fundamental DDL command there is, create.
And look, the process is just as logical as it seems. To create a table, you just give it a name, let's say users. Then Inside those parentheses, you define each column, one by one, like user ID or email. And for every single column, you assign the material, the data type we just talked about, and any building codes or constraints it needs to follow. It really is just a direct translation of the blueprint straight into code.
And speaking of those building codes, let's take a closer look. These integrity constraints, they aren't optional suggestions. Oh no, they are the non-negotiable rules that are literally baked into our structure. They guarantee the quality and consistency of our data, making them our first and honestly, our most reliable line of defense against bad data. So the most fundamental rule of all is the primary key. Think about it this way. Every single record, every row in our table needs a unique identifier. This is its street address. It's what ensures we can find any specific piece of data with zero confusion, and it guarantees that no two records can ever be exact duplicates. Next up is the foreign key. This is the magic that connects our different tables or buildings together. It's a rule that basically says a value in this table must already exist over in that other table. It's what stops you from having an order for a customer who doesn't even exist. It makes sure that all the doors in your building actually lead somewhere and don't just open into thin air.
Sometimes the simplest rules are the most powerful. The not null constraint is just a basic guarantee that a certain field has to have a value. You can't let it be empty. You can't have a user without an email address, right? Or an order without a price. It's as simple as saying, every single room in this building is required to have a floor. Period. No exceptions.
Now, here's an important one. Don't confuse unique with the primary key. They're different. A table can only have one primary key. That's its main address. But you can have multiple unique constraints. So for example, the user ID might be the primary key, but you'd also want their email address to be unique across the whole system, right? So you'd make that column unique. It's just a way to enforce that other features are also one of a kind.
Of course, no building stays the same forever, right? Business needs change, new features get added, and our data structure has to evolve along with them. So, our Architect's Toolkit also has to include some really powerful tools for renovation and, if it comes to it, for complete demolition. The two commands you need to know here are alter table and drop table. Think of it like this. Alter is like renovating with a wrench. It's for making careful, precise little changes. Drop table, however, that is the wrecking ball. It is total, it is irreversible, and it destroys the table and all the data inside it. That makes it one of the most dangerous commands in all of SQL, and you have to use it with extreme caution.
But that alter command is incredibly flexible. You can use it to add a new column. That's like putting in a new window. You can drop an existing column, which is like knocking down a wall between rooms. You can even modify a column's data type, which is kind of like changing out the flooring. It's really the essential tool for letting your database adapt and grow with your project.
And there you have it. From the initial blueprint all the way to choosing your materials. From laying the foundation and installing those critical building codes and even renovating the structure, you now have the fundamental DDL toolkit of a database architect. So the only question left is, what are you going to build?